Unit 4 is all about ratios and proportions. Let's work on a bit of vocabulary so you know what I'm talking about when I use those words. A comparison of two numbers is called a ratio. This says 2 compared to 3, 17 compared to 21, and 5 compared to 9. Now, a proportion is when the two ratios equal each other. 2 to 3 equals 10 to 15. And you can prove we have a proportion if the cross products are equal. Cross products mean cross multiply. So let's experiment. I'll do my little arrows. So I end up with 2 times 15 equals 3 times 10. 30 equals 30. Yes, they're equal. Now, there is no rule that says you have to do the top number on the left and the bottom number on the right. I simply do it that way. So in fact, I'm going to do the same math, but I'm going to go the other way. You know, I'm going to, except that's an absolute mess. So we're going to change some things around here. Those are going to be green, and those are going to be yellow. So let's do, again, I'm going to do it the way I just do it, which is 17 times 42. I use parentheses instead of a multiplication sign. 21 times 34. Now I'm going to get my handy dandy calculator out because there is no way I can do this in my head. So we have 17 times 42, and that is 714. We'll see if it equals 21 times 34. And it does. So each one of those cross products is equal. All right, we just proved it. I want to make it neater. You know how I am. You cross multiply. Now here, we're going to do the same process, but we are solving for a variable. The cross multiplication is the same. Going to cross multiply that. Going to cross multiply that. Okay? So, I have 7 times 8. It's been a long day. 7 times 8 equals 11 times x. Now let's just continue on with the math. 56 equals 11x. You know what to do. This is what you've been doing in multi-step equations. You're going to divide everything by whatever is in front of the x. And we're going to leave it as 56. So we're going to leave it like this. 56 over 11 equals x. Just leave it like that. The decimal's long and repeating. It's 5.09 repeating. If they want you to take it to 2 decimal places in Alex, this is what you write. 1 decimal place would be this, 5.1, okay? It's all the same thing. Every single piece of this is the same. All right, let's do another one. Let's see. All right, there we go. We have 8 times 12 equals 17 u. Remember, we don't write the multiplication symbol when we do a number multiplied by a variable. We just write them together. So this is 96 equals 17u. Divide both sides by 17. And so we're going to keep it as a fraction. 96 over 17 equals u. Also, 5.65 or 5.7. All of those are correct depending on what we are asking for. We may ask you to keep it as a fraction. That's perfectly fine. You can't reduce it. They have no numbers in common. Or we'll ask you to put it in a decimal. Just read the directions. Let's go to the next page. Now we're taking it a teeny bit further. My favorite question, does the process change? It does not. We are still going to cross multiply. Our equations just may look a little different. Right? We still have 5 times 8 equals, this time, it's 7 times y plus 8. 7 times whatever that numerator is. You've got to do the distributive property here. 40 equals, remember, multiply everything in the parentheses by the 7. 7y plus 56. And continue solving. The right way, not the way I'm doing it. Okay, do the t. Subtracting 56 from both sides. Negative 16 equals 7y. Then divide both sides by whatever's in front. So negative 16 over 7 equals y. Please do not switch it around and say y equals. Keep your variable where it is. You don't have to move it in this equation. Don't do that. It only makes things more confusing for you. So leave the variable where it is. All right. Ooh, this one's going to be fun. Number 4. Still going to do cross multiplication. That doesn't change. But this time we have variables on both sides. So I have negative 15x equals negative 10 times x minus 3. The only math I've done on these two equations is cross multiply. I haven't even solved the cross multiplication math. I've simply done it. Negative 15 times the variable is negative 15x, and we still have to do the distributive property to find out what negative 10 times the parentheses is. This is still, here we go. Negative 15x, there's no change there. This is negative 10x, and negative 10 times negative 3 is positive 30. Don't let that fool you. Now look at this equation. The way we have x's on both sides of the line. We want x's on one side of the line. So the only one to move is the 10x. Add the opposite. That cancels out. Now I have negative 5x equals 30. Divide both sides by negative 5. X equals negative 6. The tricky parts here are going to be keeping track of your signs. Please don't do this in your head. Please show every step. Now we're going to do applications. We're going to take the words, we're going to underline the important parts, and we're going to use them in an equation. So Austin drove 320 miles using 12 gallons of gas. At this rate, how many gallons of gas for 296 miles? Okay, I'm going to do, let's see, miles to gas. That's what I'm going to do, miles to gas. So what we have is 320 miles for 12 gallons of gas equals, look at the second part of the equation, the second part of the word problem. I'm sorry, application. Don't call it a word problem. How many gallons of gas? So we don't know the gas, so I'm going to put G down here for gas, but we do know he's driving 296 miles. So now we have the problem set up. After you set it up, you cross multiply. I have 320G equals 12 times 296. 296 times 12. So I have 320G, I'll go ahead and do this, equals 3,552 miles. Divide them both by 320. So one he'll need, divided by 320, 11.1 gallons of gas. We knew part of what we wanted. We knew how far Austin was going to drive, 296 miles, and we could use his earlier gas consumption to figure out how many gallons he would need. So we both just set up an application of the cross multiplying. All right, last one. Alex runs 4 miles in 30 minutes. It's still faster than me. At that same rate, how many miles in 48 minutes? I'm going to do this one two ways. I'm going to do miles to minutes. 4 miles in 30 minutes. That should be an arrow. Equals, we don't know how many miles, but for 48 minutes. So 4 times 48 equals 30 minutes. 48 times 4. 192 equals 30 minutes. 6.4 miles in 48 minutes. Now I'm going to set this up a different way. I want you to check it out, okay? I'm going to do minutes to miles. Let's see if there's a difference. Got minutes on top, so that'd be 30 minutes, 4 miles. 48 minutes, m miles. It's still the same equation, isn't it? Cool. So what this shows you is you can set your problem up either way, but you need to put the same things on the top of both ratios. If you're going to do miles over minutes, then both ratios have to have miles on top and minutes on the bottom. I'm going to write this down. Numerator and denominator need same units. No, not same units. Units in same places. We'll do it that way. It makes more sense. in the same places in both ratios. Okay, I'm gonna show you why it doesn't work if you don't. So we know that the black is right, we know the red is white. Let's do the yellow. I'm gonna mess it up, okay? I'm gonna do 4 miles and 30 minutes equals 48 minutes and miles. Now I have 4m equals 1440. M equals 360. He's not going to run 360 miles in 48 minutes. So this does not work. Follow the blue. The numerator and denominator need units in the same places in both ratios. But you choose which one you want to do. Okay, and that wraps up day 1.